So, but once we learned to read the difference between the word diameter and radius, it was not that hard.
That's what's giving me plus I put 0.5 instead of 0.05. That was what was
Okay. So this one's difficulty 3. Hopefully it won't be we won't have as much hard of a time as we did with the 2. Okay, notice this says 24 centimeters in diameter. So we're going to notice that this time. Within the volume of an isolated plastic sphere to produce the electric field of that just outside the surface of the sphere. Okay, so this is a little different because we got a plastic sphere, so it's an insulator. So it's not going to be 0 all inside. But for part A, well, it was a hollow sphere. So that was, even though it's not a conductor, since it's hollow, it's basically the same thing. But here, since this is a solid, well, I think it's a solid from the sound of it. It doesn't actually say it, but I just kind of felt like it should be solid. Okay. As long as we're outside of the sphere, nothing changes, though. So if we want an electric field just outside the surface of the sphere, well, I'm going to do this the second way because I like 9. 9 comes out nice and even. So,
same way, don't you?
yeah, I mean, it's just, do you like 4 pi times 8.85 to the negative 12? Or do you just like 9 times 10 to the 9? I like 9 times 10 to the 9. So,
I still don't know what you're saying.
Okay.
The whole thing anyway.
Well,
I just did it wrong way.
basically, we could do that, or we could do that, whichever one you like better. I'm saying I like this one better because we would have to compute sigma, and we would have to, yeah anyway.
What's the V2?
It's an R squared.
Oh, okay.
It still looks like a V, doesn't
I was
it?
like,
R.
Look, I haven't seen this before.
Okay. So we got yeah. Formally within the volume of that to produce an electric field. Okay, so we got so R is 12.
You sure?
Yes.
Okay.
So E, we want 1150. This is 9 times 10 to the 9th. That's Q, which is what we're looking for basically. This is 0.12 squared. So I'm going to double check them just to be sure. Because Colby made for 1150, 12 centimeters. All right, that's all good. So,
And we're looking for Q, right?
yeah. There will be one more step after we find it, but about 9 equals. Okay. So I got 1.84 times 10 to the minus 9th for Q. But that's the charge on the sphere. What it actually asks for is the number of electrons on the sphere. So how are we going to get number of electrons?
Number of electrons where? On the surface.
So they're uniformly distributed throughout the sphere. But we know what charge we want on it. How does that translate into like extra electrons?
I know there's a number I'm forgetting.
Mm-hmm.
Can't think of it.
What would be the name of that number? Yeah, what's the charge of an electron, right? Which I think is 1.67 times 10 to the minus 19th, if I remember right.
Something like that.
So let's try it, and if it's wrong, we'll actually look it up. I can do that because I don't get points counted off when I put in a wrong answer the first time.
You know, you could do that to us. That would be nice.
So 1.10 times 10 to the 10th. Yes. Not quite.
No, you're close. Around the
Close. All right. In that case, I think I know what the charge is. I think it's 1.608 instead of 1.67.
Or is it 1.8?
Well, one of them is, no, it's not 1.8. It's hard because one of them.
I'm gonna laugh if 1.09 is, it counts it right. 1.1.
Yeah. Okay. 1.602. Okay. I can never remember because the mass of a proton.
So you could just put 1.6.
Yeah.
1.67.
Yeah.
Gotcha.
The thing is, the mass of a proton is the 1.67. The charge is the 1.60, and I always get them backwards in my head. So.
Oh, the mass. Gotcha.
Yeah. So this was with 1.67, so I need to divide by 1.67 and times by 1.6. So 1.06 instead of 1.1. Oh, no. Unless I just should have started over instead of, oh, yep, I did. I did backwards. So I had 1.1. I needed to times by 1.67 and divide by 1.6. It goes to show you should probably start over instead of trying to jerry-rig
I
it.
would.
But again, I don't get points counted off if I. All right. Cool. What's the electric field that far outside the surface of the sphere? It's the same thing. Just go back to. We know what Q is now. It's that guy. So now you're just going to add the extra distance there. So you're going to go 9 times 10 to the 9th times our Q, 1.84 times 10 to the minus 19th. And then divide by the radius, which, what was it? So our radius was 0.12. We're going an extra 0.105, so 22.5 centimeters. So yeah, not too bad, not too bad. So we got 9 times 1.84. If I can move my calculator to a spot where I can actually put the point in. Divide by 0.225. 73.6, and then I'll have a 10 to the minus 10th. So that's 7.36. Did I?
No.
Okay. I'll believe you. And I'm going to start over instead of jerry-rigging it, unless one of us, because, I mean, yeah. 0.225 squared. You're right. I remember not hitting that key. Okay, 3.27, and then that's 10 to the minus 10th, so it'll be 10 to the minus 8th when we move the decimal twice. So 3.27 times 10 to the negative 8th. What did I do that time? There's no way the answer is that small.
Why not?
Because it's 1150 just outside the surface. There's no way it dies off that quickly. Oh, because I copied the charge wrong. The charge was 1.84 times 10 to the minus 9, not 10 to the minus 19.
I didn't even notice that because I wrote it on 9 by mine.
Okay, so
Sorry, I didn't notice both mistakes.
Colby, you know I need you to fix me whenever I mess up.
Hey,
So it should just be 327.
figured rub it in, rub it
All right.
in.
So if I can tell the difference between a diameter and a radius.
Yeah. It was 3.